Hello, Mr. P here, and today we're going to talk about how to factor fully under any circumstances. So we can be able to factor any type of method based on this kind of strategy here. Okay, so we're going to factor all of these questions here. So this right here is going to be our guide, our tree to how to factor. Okay, so step one, always, if you can, common factor. Okay, so that's the first thing you always want to do. And sometimes you might be done at that stage, but you got to look if there's more things to do. So common factor first. After you common factor, determine how many terms you have. Okay, so if there's 2 terms left, then you need to see if you have difference of squares, right? Difference of squares should be some variable that is a perfect square and have a minus for the difference and have a second number or variable that is also a perfect square. Okay, if that's the case, then factor it using difference of squares, and then in that case you are done. Okay, so that's if there's 2 terms. If there's 3 terms, then you have 3 possible options. Okay, ideally you want to check for the perfect square trinomial because that's probably the quickest way to factor it if you can. So you always want to check for that first. And that's kind of similar to difference of squares, right? So that's when you have the a squared plus 2ab plus a b squared, where the first and last terms are perfect squares, and the middle term is twice the value of a times b once you figure out what that is. Or the other version of the perfect square trinomial is the same thing, but we have the minus before the 2ab. Okay, so you want to factor that quickly first, or check that first. If it is not a perfect square trinomial, and you'll know it will be because you'll see the perfect squares, right? If it's not, then you're hoping that it is a simple trinomial. And you know it'd be a simple trinomial if it is of the form x squared plus bx plus c, where b and c are just numbers or integers, but specifically there is a value of 1 in front of the x squared. So you don't actually show the 1, but there's a 1 there. That's how you know it's simple trinomial. And that's easy. You just need 2 numbers to add to b that multiply to c, and you basically shove your answers right into your factored answer and you're done. So that's pretty much a one-step problem. The one you want to avoid at all costs is the complex trinomial, because that's the most amount of work. But in some cases, after you common factor it, you have no choice but to complex factor this thing. Okay, and the complex factor one looks like a simple trinomial, except now you have a number in front of the x squared. So it's ax squared plus bx plus c, where a is some number. It could be -1, could be positive 10, but there's a number there now. And there's just a couple more steps you have to do for that case. So this is how we're going to factor anything from now on. We're going to follow this guideline. Okay, so first one here, factor fully. 2x squared minus 32. Okay, so step 1, common factor, right? So what can we common factor out of here? 2x squared minus 32, we can take out a 2. So let's start with that. Take out a 2. And to see what's left, we're going to divide these by 2. Okay, so 2 divided by 2 is just 1. So we're basically left with x squared there. X squared. And then negative 32 divided by 2, we get negative 16. Okay, so we common factored. And now we are left with 2 terms in this bracket. So we look on the 2 term side of this tree. So now we might be done, but we have to check if we have difference of squares. That's our only option. If it's not difference of squares, we're done. But if we're looking at this x squared minus 16, x squared looks like a perfect square. There's a minus, and 16 is a perfect square, so this is going to be difference of squares. So now we have to factor it as difference of squares to factor it fully. Okay, so just to double check it, so our a squared term for difference of squares, remember, is the x squared. So if a squared is equal to x squared, that means our value of a will be equal to the square root of x squared, which is going to be x. And then similarly, if b squared is equal to 16, if we solve for b, we square root the 16, and we get 4. Okay, so perfect squares, and we have the minus in the middle, so we can definitely do this as difference of squares. So to finish our answer, we just go basically x plus b, x minus b. So our x value is, a plus b, a minus b. In this case, that's going to be x, and then b is 4, 4, 4. Finish off with a plus minus. And of course, we cannot forget that outside 2 value we need to include. Okay, and this is our fully factored answer here, right? We common factored first, checked we had 2 terms, so we had to check for difference of squares, and it was, so that's as far as we can go there. Okay, next example, we're going to factor this thing fully. Okay, step 1, like always, common factor if you can. So let's common factor out of this thing. So out of a 4, 2, and 10, it looks like we can take out a 2. And out of the variables, x, 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 there's at least one x in each one. And we can't take out y's, and we can't take out z's, so that's as much as we can take out 2x. Okay, so let's divide everything by 2x, 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 2x. So 4 divided by 2 becomes 2. The x's will cancel, and we're left with a y there still. So we get 2y. In the middle, it's going to be negative. 2 divided by 2 is cancels. X divided by x cancels, and we're left with z. So negative z. And then we get positive, so it's going to be plus. 10 divided by 2 is 5. And then the x's cancel there. Okay, so that's what we get after we common factor it. We did step 1. So now we can never do anything with the outside term. That's as far as it gets. But inside we have 3 terms here, right? 2y minus z plus 5. So we have to ask ourselves, is this going to be a perfect square trinomial, a simple trinomial, or a complex trinomial? And the answer is no, because right off the bat, none of our variables are the same, which is an issue, and there's no variable that is squared, right? In order to be any of these trinomials, it has to have, for example, an x squared, an x, and then a number, right? But there's not even any patterns that relate to that. It's you have a y, a z, and a number. So in this case, we stop right there, and this is our fully factored answer. All we did that one is common factor. Next one. Okay, we're going to factor 8x squared minus 8x plus 2. Again, step 1, like always, you guys know the drill now. Common factor first, if you can. So from an 8, and a 2, technically negative 8 in the middle, looks like we can take out a 2 here. So we're going to divide out a 2. So divide out a 2. So the first one, 8 divided by 2, is going to give us 4x squared. Negative 8 divided by 2 in the middle is going to be negative 4x. And last one, 2 divided by 2 is just going to become a plus 1. Okay, so we common factor first, and it looks like we have 3 terms left in that bracket. So now we have to check the 3 term side, right? So it can either be a perfect square trinomial, simple trinomial, or complex. So right off the bat, we know for sure this is not simple because there is a number in front of the x squared. So this, it will be complex. We can definitely factor this complex, but we want to avoid that at all costs. So we want to check if it's perfect square trinomial because we have that number in front. So we see the 4, x squared, looks like a perfect square. And we see the last term, the positive 1, that also looks like a perfect square. So let's check if this is a perfect square trinomial. Okay, similar to difference of squares. So we're going to go a squared is the first term equals 4x squared. So that means if we solve for a, we get the square root of this thing, which is going to be 2x. And then that works. So that is a perfect square. Sorry, yep. And then let's check the 1. B squared equals to 1. If we solve for b, square root of 1 is going to be 1. So those are both perfect squares. Now we got to check the 2ab. So check 2ab. So 2 multiplied by a, which is now 2x, multiplied by b, which is just a 1. If we multiply that all together, 2 times 2x times 1, we get 4x. And 4x is identical to the middle term. We ignore the plus or minus in front of it. The value is the same, the magnitude. 4x is 4x. So this is a perfect square trinomial. So we can quickly go ahead and factor this thing. So this is the negative version because we have the minus as our first symbol there. So our factored answer is basically going to be a minus b in bracket squared. So we just got to shove it all into there, and then we'll get our final answer. So we will get our a value is 2x. 2x. We're going to get a minus, and our b value is 1. Square this bracket. And last thing, don't forget that 2 that we took out from the very beginning. Just put a 2 there. And there is our fully factored answer, right? As soon as you factor it using any of these 3 methods, or any of these bottom 4 methods, really, you can't go any farther. That's as far as you get. Okay? So 2x minus 1 squared. You got 2 more we're going to do. Factor this one fully. X squared minus 5xy plus 6y squared. Okay? So first, you guys got it, common factor. But it looks like there's nothing in common that we can take out here. So that's fine. We tried to common factor, but we couldn't. So we just skipped that step. Now, how many terms we have? Looks like we got 3 terms, right? 1, 2, 3. So anything on this side is done. So 3 terms, it's either going to be a perfect square trinomial, simple trinomial, or complex. Okay? So looking for a perfect square, we have the x squared at the beginning, which is promising, but the 6y squared is not a perfect square. So this doesn't work for a perfect square trinomial. Now we look at simple trinomial. Again, we want to avoid the complex trinomial. So simple trinomial, we need a 1 in front of the x squared, or no symbol, which represents a 1, no number, which represents a 1. And that's exactly what we have. So this is going to be a simple trinomial. So we kind of got lucky there. Okay. If it was complex, there would be some value in front here, like a 3 or some number, or a -1. Okay. But we're going to end up doing simple trinomial here, which is not too bad. This is just the double variable one, right? So we're going to act x as a variable, which means -5y is kind of like our middle number there, right? And x is a variable. So here we need 2 numbers to add to -5y. So add to -5y, and we're going to multiply to positive 6y squared. Positive 6y squared. Okay, so let's list our factors of 6y squared. We can do y times 6y. We can do -y times -6y. We can do -3y and -2y. You can do positive 3y and positive 2y. And that's all of our possibilities. So which of these adds to the -5y we wanted? Looks like it's going to be -3y and -2y. Okay, so once we figure those out, this one's easy. It's just simple trinomial. So we just need to put those numbers in our brackets to get our answer. So let's do this a different color. So our final answer will be brackets. Our variable comes first, right? Our variable was x. So we go x here, x there. And then our 2 numbers, -3y in one bracket and -2y in the last bracket. Okay, so that one was simple trinomial, not too bad. One more question here. Okay, 6s squared minus 7s minus 3. Okay, step 1, you got it. Common factor if you can. Can't take out any s's because there's not an s in every term, and we can't take out anything from a 6, a 7, and a 3. So we tried the common factor, but there's nothing we can do there. Then we check our terms. We got 1, 2, 3. So nothing on the left. See if it's perfect square trinomial. We have a 6 and a 3, which are not perfect squares, so unfortunately won't work. Check to see if it's simple trinomial. We have the 6 in the front, which is not a 1, so unfortunately that doesn't work. So this is the one scenario you try to avoid, but unfortunately we can't avoid it here. It will be a complex trinomial. Okay, but still, even though it's complex, it's not really complex. So here, let's do this one. So complex, we need 2 numbers to add to the middle term, so we're adding to -7, and we're going to multiply to our coefficient on the first term multiplied by the full constant at the end. So 6 times -3, that's going to be -18. So we're going to multiply to -18. Okay, so list your factors of -18. And you want it to add to -7. So we can do 1 and -18. That adds to -17, doesn't work. We can do -1 and +18. Doesn't add to -7. We can do -2 and 9. That adds to +7. We can do -3 and 6. Doesn't work. We can do 3 and -6. Also doesn't work. Or we can do 2 and -9, and that will add to the -7 we wanted. So that's going to be our pair of numbers there. Okay, just remember, for complex, we have to unfortunately replace our middle term with those two new numbers. All right, there's a couple more steps here. So we're going to go 6s squared, that stays the same. Instead of -7s in the middle, we're going to do plus 2s and minus 9s, right? Those are both of our numbers. And since we're replacing the middle term, which was an s, it had an s on it, we have to add s's to these numbers. And then, of course, that -3 chills at the very end there. Okay, so now what you want to do after you have your 4 terms, slice it in half right after the second term, just temporarily. And we're going to common factor, technically common factor, both sides on their own, right? So on the left, 6s squared plus 2s, we can take out 2 s's. And if we divide 2 s's here and there, 6 divided by 2, we get 3. S2 divided by s, we get 1 s left over, so 3s. 2 divided by 2 is 1, s divided by s is 1, so we end up with nothing, which really means it's a plus 1. So 3s plus 1, and sorry about this dot there. And on the right side, a -9s minus 3, we can take out a -3. And if we divide -3 here and -3 here, we should be left with the exact same bracket, right? So negative divided by negatives cancel. 9 divided by 3 becomes 3. And then the s is still there. And then on the right side, the negatives cancel, so it's going to be plus. And 3 divided by 3, of course, is going to become 1. Okay, so we had to take out that negative there, because if we only took out +3, we'd be ended up with -3s plus 1 in the bracket, which is not identical to this bracket over here. We need them to be identical to finish this off. So we had to take out that negative to make sure we get the exact bracket there. Okay, so now since these brackets are the same, we can go ahead and common factor those out. Almost done. So we take those out, we get 3s plus 1 as our first factor, first bracket. And then if we technically divide these as we take that out, then those full brackets are going to cancel on top and the bottom. So when we get our remainder bracket, we're left with 2s, so 2s. And on the right side, if we cancel both those brackets, we're left with -3. Okay, and that is our final answer for that one. Okay, so you want to avoid complex factoring, complex trinomial if you can. So whenever you have 3 terms, check if it's perfect squares. That's the quick one. And if not, hopefully it's simple trinomial. If not, then you will have to do complex like we just did here. Okay, that is it for this one.